Be very difficult to understand and sort, which usually leads to misinterpretations in the data. Our group decided to create a program that analyzes Detroit crime rate data from 2016 to 2018 that provides predictions, statistics, and visual representations that allow the user to clearly understand the data. The reason we chose this data was to obtain useful and applicable knowledge about criminal activity in Detroit, and it was a great opportunity to learn more about the city we live in. This was the data that we worked with. It gave us all the offenses and the reasons that people called 911 in Detroit for these 3 years. We were given offense categories, year, incident date, time, precinct, zip code. This was a neighborhood. These were all used in our program to make it easier for the user to understand the large data set. The first thing that we do once we run it is it will load our crime rate data. That was the first line of the program. And then there is a while loop that allows the menu to keep coming up until you select exit. Our main menu has several options to choose from depending on what the user wants to know. If the user selects option 1, another user-defined function named precinct number data is going to be called. In this part of the program, we calculate how many times each precinct responded over the years 2016, 2017, 2018. So over here, what we do first is we extract the precinct number and incident date time from the data, and we have nested for loops and if-else statements that run through the entire length and the rows and columns of our data and count how many times a precinct was called for a specific year, depending on if this condition is true. This is done 3 times for all 3 years, 2016 and 2018. After we get those results, these are displayed in the command window using fprintf. So as you can see in the results here, a bar graph will also pop up with showing you the precinct numbers and how many times those precincts responded for an average of all the 3 years. And to be more specific, in the command window, we give you the exact number of times the precincts were called. Now back to the main script. If I were to select yearly statistics, this is option 2. Another menu is going to pop up over here. And what this does is it allows you to choose a year so you understand, you can basically break down the data and understand what happens during each specific year. This main menu gives you the 3 years to choose from, and within the while loop there's the switch case that assigns the output from the menu to a variable that's going to be used in the next function. So over here, this project years function, once I select a year, another menu is going to pop up that will allow you to choose what you want to know. Would you like to know most common, least common, or would you want a histogram representation of everything? So if I were to choose option 1 here, so if Q input is equal to 1, what we do first is we extract all the offenses from that specific year and use the mode command to find the most common one and to find the frequency of it. And this is displayed in the command window over here for that specific year. If we select option 2, which is least common crime and table, instead of using the mode, because we're trying to find the least common, a for loop is used to count the number times offenses occurred during that specific year and assigns them each to a counter variable. Over here, a table is created with the offenses and how many times they occurred, and this for loop over here is created just in case there are multiple minimums, so it displays all of the options that we are given. So for example, here in the command window, the result is the table that I just talked about, the offense categories and occurrences. It also gives you the list of the minimums. If we select option 3, which is histogram and table representations, 2 functions are going to be called. The first function is the plot input, which basically extracts all the data on the offenses for that specific year that are going to be plotted. And then that output is going to be the input for the plot graph, which takes in all that data and creates a histogram and a table. So if I were to select that option, the histogram with a list of offenses for that specific year and the number of times they occurred comes up, along with a table that shows offenses, occurrences, and the percentage. And then if we press exit, it's going to take me back to the main menu. Now, if the user selects option 3, which is hourly statistics, we sort data here based on years, so you know which hour is most common for a crime to occur in. So once I select hourly statistics, it calls the function hour menu. Hour menu, so this function is going to keep coming up until you press exit. This is done using a while loop. And with the while loop, there's going to be a switch case that assigns each variable the output to a variable that's going to be used in the hourly function. This function extracts the 5th column and 10th column, which are the offenses in hour of the day, to compare them, count how many times an offense occurred during that specific hour. This is all done using a for loop, and within the for loop there's an if-else statement that counts all the offenses that occurred during an hour. After that is done, we plot them, and we used polyfit and polyveil to create a prediction graph. So over here, once you press that, a graph is going to pop up right here. The dotted line is the actual, and then the prediction is done with a solid line to give you a predicted value of what might happen if you want to look at other years for that specific crime. And then in the command window, it's going to ask you to input a time. So let's say I want to look at hour 8. It's going to give you a predicted value between the actual value and the prediction that we made. So once I press exit, it's going to take me back to the main menu where we can go and look at the holiday and crime correlation over here. The goal of this was to analyze crimes during specific holidays in order to gain some understanding of how cultural celebrations influence crime occurrences in Detroit. 2 questions are proposed. The first question is to look at data regarding the past, such as 2017, or make predictions for the future, 2018. From the 5 holidays, the user should be able to look at the data visualized in 3 different ways to understand how the holiday influences people's behavior. So the first thing that we do is it calls our main script calls this function, and this function extracts all the data that's going to be used later on and gives you a menu with all the holidays that you can choose from. Once you select a holiday, another menu is going to pop up. This is all done using while and if else. The menu is going to pop up allowing you to choose between 2017 data or 2018 prediction. If you select 2017 data, 2 functions are going to be called. The first function is going to be called project 2017 data. What this does is it extracts all the rows for which the day, the year, and the month equal to that specific holiday and assigns it to a crime rate index cell array. This is done 5 times for all of the 5 holidays. After that, the next function that's called is the project graphs, and what this does is it creates a table, a bar graph, and a pie chart. So once I select 2017 data, you're going to get 3 visualizations. Here, this is the pie chart showing you the percentage of each offense for that holiday, which was 4th of July. And then this one tells you the offenses and the total number of offenses on that holiday. And we are also given a table here in the command window. Now, if I were to have selected option 2, so let's go back to holiday crime correlation, 4th of July. Option 2 gives you a 2018 prediction. Another 2 functions are going to be called. The first function basically does the same thing as the project 2017 data, but creates 3 crime rate indexes in order to count for the day before, the day after, and the day of the holiday. And it uses a for loop. Over here, after it finds the rows, each day shows up and finds the month and year intersection for each day in the for loop over here so that we can create the prediction. This is done 5 times for all of the 5 holidays. The next function that's going to be called is the 2018 prediction, and this is what outputs. This takes in all the crime rate indexes and outputs a prediction. It finds the size of all the crime tables and puts them into a value, and then finds the largest and the smallest values using min and max. The if-else statements here are used to find determine the largest or the middle value over here. This is done for all of the holidays. Then we have nested for loops to compare each crime in both tables and sum the total occurrences from both of the tables. Over here, after we do that, we have for loops cycling through the sum of all of them to find the largest and the second largest value, and it assigns them to a variable. And then we find the name of the most common crimes and get the average of those, and that's what's displayed in the command window. So over here, we get the prediction of what might happen based on the day before, the day of, and the day after the holiday. Now, once I go back to the main menu, over here we can look at the neighborhoods. This gives you a menu. This allows you to sort data so you can figure out what type of crimes happen during in certain neighborhoods. So when this function is called, we are given a switch case that assigns each output from the menu to a variable. So if I were to select, let's say, Warrendale, for example, it gives you the crime rate statistics for Warrendale. This calls another function that basically extracts all the data from the offenses and for the neighborhood and compares the two and counts how many times each one occurs, and then it displays a histogram. After that, we could go back to the main menu and we can figure out the most common day for a crime. This gives you a plot that gives you the most common day for all of the years, and in the command window, we display what day was most common for each specific year. This is done using the most common day crime function. And what this function does, it extracts the day column and the year column and compares the two to figure out which ones were most common. This is done 3 times for all 3 years. And then we plot them. And to make it easier for the user to understand, we use multiple if-else statements to convert the numbers like 1 to the day Sunday so it can be easier read by the user. So that was basically our project, and this project helped me better understand, get a better understanding of MATLAB and everything that's capable of doing. It allowed me to learn more about how, what functions to use and how to make them communicate with each other. And it gave me an opportunity to apply everything that we learned in class into the program to solidify the concepts. I now understand what functions or loops and visualizations to use when looking at large data, and I learned a lot about what crimes occur most in Detroit.